The surge protector's ground light not illuminating suggests a potential grounding issue. Firstly, verify all wiring connections at the electrical panel, junction boxes, and the surge protector itself. Ensure all connections are tight and look for any loose or damaged wires in the circuits you are inspecting. Secondly, confirm that the neutral and ground wires are bonded together at the electrical panel. Inspect the bonding straps for any breaks or signs of corrosion. Next, measure the ground resistance. Use a ground resistance tester to measure the resistance between the ground wire and the grounding electrode, which is usually a copper rod buried underground. A reading of less than 25 ohms indicates a good ground. Then test ground wire continuity. With the breaker off, use a multimeter to test the continuity between the ground wire at the surge protector and the grounding electrode. A reading of less than 1 ohm should be obtained, indicating a good ground connection. After this, check for stray voltage. Use a voltmeter to measure the voltage between the ground wire and other conductive surfaces such as water pipes or metal studs. Stray voltage should ideally be less than 2 volts. Then inspect electrical appliances. Unplug any appliances that may be malfunctioning and test the ground again, as a faulty appliance can sometimes leak voltage to the ground. If you are unable to identify the source of the problem, contacting a licensed electrician is the next step to further investigate and resolve the issue safely. The absence of the ground light illuminating on the surge protector doesn't automatically indicate a loss of ground. However, the reported stray voltage reading of 20 volts is concerning and suggests a potential problem with the grounding system. It is vital to address this issue promptly to prevent further electrical hazards and potential damage to appliances. When performing continuity tests with a multimeter on electrical circuits, always ensure the power is off at the breaker to prevent electrical shock. If voltage is measured between neutral and ground, this typically indicates a problem. A properly wired system should have minimal voltage between these points. The shared neutral wire, in what sounds like a multi-wire branch circuit, could be overloaded if the loads on the two hot wires are unbalanced, leading to voltage drop on the neutral. An overloaded neutral can cause the voltage on the circuits to fluctuate and create a shock hazard. The fact that both upstairs rooms are experiencing the same issue indicates a potential problem at the electrical panel or in the wiring between the panel and the first outlet in each circuit. Start by carefully inspecting the connections at the breakers and the neutral bus bar in the panel. Look for any signs of corrosion, loose wires, or damage to the insulation. When checking for continuity between neutral and ground with the breaker off, the absence of continuity might seem confusing, but it is not necessarily an issue. The neutral and ground are only bonded together at the main panel, and there should be no direct connection between them at any other point in the system. The presence of voltage between neutral and ground while the circuit is energized can sometimes create a false reading of continuity when the circuit is de-energized. The 100 volts reading from hot to ground, when it should be close to the hot to neutral voltage of 120 volts, indicates a significant problem with the grounding system. It suggests that the ground wire is not providing a low resistance path back to the source. This could be due to a loose connection, corrosion, or a break in the ground wire somewhere in the circuit. The fried computer is a serious consequence of a faulty grounding system, as it means that stray voltage and current are finding their way onto the equipment grounding conductors and potentially damaging sensitive electronic components. Be sure to use a properly rated multimeter for electrical testing. Ensure that the meter is set to the correct range and function before taking any measurements. If unfamiliar with electrical testing procedures, consult a qualified electrician for assistance. When inspecting wiring connections, look for signs of overheating, such as discolored wires, melted insulation, or burned connections. Overheating can occur due to loose connections or overloaded circuits. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, it is recommended to hire a qualified electrician to perform the necessary troubleshooting and repairs. Neutral and ground wires serve distinct purposes in an electrical system. The neutral wire carries the return current from the load back to the source, while the ground wire provides a low impedance path for fault current to flow back to the source in the event of a short circuit or ground fault. The ground wire is connected to all metal enclosures and equipment, providing a safety path for current to flow back to the source, tripping the breaker and energizing the circuit in the event of a fault. The fact that you have already checked most of the wiring on both circuits without finding any obvious problems suggests that the issue may be more subtle or intermittent. It is possible that there is a loose connection or damaged wire that is only making contact intermittently, or that the problem is located in a less accessible area, such as inside a wall or ceiling. If the issue persists despite your best efforts, it is definitely time to call a licensed electrician to perform a more thorough investigation. They will have the tools and expertise to diagnose the problem and make the necessary repairs to ensure the safety of your electrical system. Multi-wire branch circuits can be complex to troubleshoot, especially when they share a neutral wire. If one of the hot wires is heavily loaded while the other is lightly loaded, it can create an imbalance in the neutral current, leading to voltage fluctuations and other problems. Be sure to check the load on each circuit to see if there is a significant imbalance. If so, try to redistribute the load more evenly between the two circuits. When checking the ground connections, pay close attention to the connections at the grounding electrode. This is typically a copper rod driven into the ground near the electrical panel. Make sure that the connection between the ground wire and the grounding electrode is clean, tight, and free of corrosion. If the grounding electrode is corroded or damaged, it may need to be replaced. Stray voltage can be caused by a variety of factors, including inductive coupling from nearby power lines, ground loops, and faulty equipment. It is important to identify the source of the stray voltage and take steps to eliminate it. In some cases, it may be necessary to install a ground filter or other device to reduce the stray voltage. If the hot water heater is suspected of leaking voltage to ground, disconnect it completely from the electrical system and then check the voltage between neutral and ground. This will eliminate the hot water heater as a potential source of the problem. It is important to understand the difference between a ground fault and a short circuit. A ground fault occurs when current flows from a hot wire to ground, while a short circuit occurs when current flows directly from a hot wire to a neutral wire or another hot wire. Both ground faults and short circuits can cause breakers to trip, but they are caused by different types of problems. If the surge protector's ground light is not illuminated, it is possible that the surge protector itself is faulty. Try plugging the surge protector into a different outlet to see if the ground light illuminates. If not, the surge protector may need to be replaced. Before doing any electrical work, always turn off the power of the breaker and verify that the circuit is de-energized using a non-contact voltage tester. This will help to prevent electrical shock. When working with electrical wiring, always wear safety glasses and gloves to protect yourself from injury. It is also a good idea to have a second person present in case of an emergency. If you are not sure how to do something safely, it is always best to consult a qualified electrician. Remember, electricity can be dangerous, and it is important to take precautions to protect yourself and others. Always follow all applicable electrical codes and regulations. Electrical codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. It is important to be familiar with the electrical codes in your area and to follow them carefully. If you have any questions about electrical codes, consult a qualified electrician or electrical inspector. When troubleshooting electrical problems, it is important to be systematic and methodical. Start by gathering as much information as possible about the problem, including when it occurs, what symptoms you are observing, and what you have already tried. Then, develop a plan for troubleshooting the problem, starting with the most likely causes and working your way down to the less likely causes. Be sure to document your findings as you go, so that you can keep track of what you have already tried and what you have yet to try. Be aware of backfeeds. Backfeeds can happen when current flows back into the electrical system from an unintended source, such as a generator or another circuit. Backfeeds can be dangerous, as they can energize circuits that are supposed to be de-energized. To prevent backfeeds, always disconnect the main breaker before connecting a generator to your electrical system. If you are not sure how to do this safely, consult a qualified electrician. Always make sure that your electrical system is properly grounded. Grounding is essential for safety as it provides a low impedance path for fault current to flow back to the source in the event of a short circuit or ground fault. A properly grounded electrical system will help to protect you from electrical shock and prevent damage to your equipment. Check the condition of the wiring in the electrical panel. Look for any signs of damage, such as cracks, breaks, or corrosion. If the wiring is damaged, it may need to be replaced. Also, check the tightness of the connections in the electrical panel. Loose connections can cause overheating and other problems. If you find any loose connections, tighten them carefully. Be sure to turn off the power to the panel before doing any work on it. Check the condition of the breakers in the electrical panel. Look for any signs of damage, such as cracks, breaks, or corrosion. If a breaker is damaged, it may need to be replaced. Also, check to make sure that the breakers are properly sized for the circuits that they are protecting. If a breaker is too small, it may trip frequently. If a breaker is too large, it may not trip when it should, which could create a fire hazard. Replace any damaged or malfunctioning outlets or switches. Damaged or malfunctioning outlets or switches can be a safety hazard. If you find any damaged or malfunctioning outlets or switches, replace them immediately. Be sure to turn off the power to the circuit before replacing any outlets or switches. Consider the age of your electrical system. Electrical systems typically last for many years, but they do eventually wear out. If your electrical system is more than 25 years old, it may be time to have it inspected by a qualified electrician. They can identify any potential problems and recommend any necessary repairs or upgrades. Think about upgrading your electrical panel. If your electrical panel is old or outdated, it may not be able to handle the demands of modern appliances and electronics. Upgrading your electrical panel can improve the safety and reliability of your electrical system. It can also increase the value of your home. Have a qualified electrician inspect your electrical system regularly. A regular inspection can help to identify potential problems before they become serious. It can also help to ensure that your electrical system is up to code. A qualified electrician can perform a thorough inspection of your electrical system and provide you with a report of their findings. They can also recommend any necessary repairs or upgrades. If you notice any unusual smells or sounds coming from your electrical system, investigate them immediately. Unusual smells or sounds can be a sign of a serious electrical problem. If you smell burning plastic or see sparks coming from an outlet or switch, turn off the power to the circuit immediately and call a qualified electrician. Never ignore electrical problems. Electrical problems can be dangerous, and they should never be ignored. If you notice any electrical problems, have them repaired immediately by a qualified electrician. Ignoring electrical problems can put you and your family at risk. Finally, consult a qualified electrician. If you are not comfortable working with electricity, or if you are not sure how to solve a particular electrical problem, consult a qualified electrician. A qualified electrician has the knowledge, skills, and experience to diagnose and repair electrical problems safely and effectively.